Hi and welcome to this monitor calibration tutorial from EIZO. In this tutorial we're going to be using DisplayCal to calibrate the CG319X and the CG279X using a 3D LUT. DisplayCal doesn't talk directly to the EIZO monitors to be able to upload the LUT, so to be able to work and use DisplayCal we need to use that in a combination with EIZO's free calibration software called Navigator 7. So Navigator 7 allows us to upload that 3D LUT into the CG319X or the CG279X for use in color grading. So at the end of the tutorial you'll be able to use DisplayCal to generate that high precision 3D LUT and have your monitor able to work in the most critical color environments. DisplayCal doesn't communicate directly with the EIZO monitor, so therefore it doesn't have access to the internal test pattern generator or the internal probe, and you can't directly upload a LUT from DisplayCal. So to do that, what we need to do is actually use a combination of DisplayCal with Navigator 7. Navigator 7 being the free software that comes available with the CG series EIZO monitors. And what that allows us to do is we need to go and calibrate the CG319 first to be able to upload a 3D LUT. So it sounds a bit strange. So when you open up Navigator 7 you'll see this little window coming up because our grading monitor is connected via a Blackmagic card in this case, or it could be an EIZO card or a Bluefish card as a grading monitor. But it is connected, so your EIZO monitor needs to be connected via the USB cable. And so with this workflow it does actually have some advantages. The advantages are that Navigator 7 will do the 1D LUT for you. So therefore it will pre-calibrate the monitor to a very high degree before you actually start profiling with DisplayCal. So when you open Navigator 7 you select the Cal slot down here. And there's one really important selection that we have to make within Navigator 7 before we start to calibrate. Navigator 7 is primarily designed from a photographic background, and as such it uses ICC profiles. In our post-production workflow we're not using ICC profiles, as our main monitor, our EIZO monitor, is connected via a third-party card, in this case a Blackmagic card, but it could be an EIZO card or a Bluefish card of some sort, but it is not using the graphics output of the computer. So what we need to do is to go up to Preferences, select Preferences, and then in the General tab we have to go all the way down and make sure we select this tick box, Do not apply an ICC profile. You remember when we had that first dialog box we quickly came up and said OK? Well, that means that if we didn't click this box, an ICC profile would be created by Navigator 7 and applied, which is actually then for the GUI, which is incorrect. So we want to make sure that we don't apply any ICC profiles to the GUI monitor that we're using to drive Navigator 7 when we're going to calibrate our monitor. Another setting that needs to be considered if you're going to be using the i1 Display Pro in a combination with Navigator 7 and DisplayCal is the fact that the i1 Display Pro has built-in spectral data based on a batch that X-Rite put into that i1 Display Pro. The files are called EDR files, and what they are there for is to create a correction offset for certain display technologies. So they can vary. Within Navigator 7 it uses the RG Phosphor Family 25th July 12, which is a standard offset that X-Rite has within the i1 Display Pros. But what Navigator 7 engineers have done at the factory is also to have created some additional offsets to make it more correct for the spectral displays of the EIZO monitor. And that's automatically selected when you start Color Navigator up. So if you choose the same offset, the same EDR file in DisplayCal as used in Color Navigator 7, it's highly likely that you will find that there's a measurement difference. If you have a goal of taking away that difference, the way you can turn off the additional correction offsets created within Color Navigator 7 is to go into Preferences, and in the Color Management is to select the No Compensation. The No Compensation method will just use the straight EDR file that's created installed by X-Rite for that i1 Display Pro. So if you use that method and use the same EDR file within DisplayCal, and those EDR files can be found here under the correction, and the EDR file that is the RG phosphor family is this one here. If you hold it, you can see that RG phosphor family, 25th July 12. That means that EDR will match this EDR. That does not mean that your i1 Display Pro will be absolutely correct for this specific display, but it does mean that the Color Navigator 7 measurement and the DisplayCal measurement will equate to each other because the measurement is being done by the i1 Display Pro and then reported back to the software. So the choice is yours, but if you use that, there's a highly likely that you will get some difference because you're using different offsets between the two different programs. What we need to do is we need to go and select our target. So we can go and create a target. So we can edit this target up. And so we might call this target DisplayCal. DisplayCal native. And the reason being is because I'm going to actually leave the color gamut at its native wide gamut, but calibrate the grayscale correctly. So we've got 100 nits as our standard luminance level. Black level is always at minimum. The color temperature you can choose from the slider, but it is easier to just go and select D65 like that, and you can see the chromaticity points for D65 there. For the gamma, we're going to choose a standard gamma curve of 2.4. Like so. And all the rest we're going to leave. So we're going to leave the colour gamut in its native mode. So we're going to be calibrating in a grayscale, but in the native. It's quite a common thing to do in the photography world, but not that common in grading world, if you like, because we normally just do it in one hit. So we go OK, so we've got that selected there. You can see our different values. Now we can also label this slot. So this Cal2, if we right click on that, we can rename that. So that'll appear when you look into the menu of the monitor to choose your color mode. Okay, so once we've done that, we can then start to calibrate it. So you can use a number of different functions. You can use the inbuilt sensor, or if you've got an i1 Display Pro, which is what you would need really for DisplayCal, you can use the i1 Display Pro as well. So in this case, we'll leave the i1 Display Pro here. It does have offsets already created for it in the Color Navigator software. So this is an OEM probe, so Color Navigator 7 will work with the retail version as well as the OEM versions of the i1 Display Pro, which is quite useful. So it'll just go through and start measuring the patches in the grayscale, and this will just take a few moments. You can see here the actual wide gamut nature. It's just gone and done the grayscale balance, but you can see the wide gamut of the native display. Okay, so that's now finished. It's given you the measurement points where it got to. adjustment and the chromaticity points for the native primaries. So once we've done that, we can hit the finish. So what that allows us to do now is to go and profile using DisplayCal, and then we're going to load the LUT using a function that's called log view LUT in Color Navigator 7. So that's really designed, I guess, from the initial thoughts to load if you had an S log or a V log or a log C from an Array Alexa type thing to make a look type LUT within that and load it into the system, because this already can be calibrated Rec 709 if you like. But this slot is actually also, it's in line in the color pipe, which we use for creating a 3D LUT for calibration of the monitor. So once we've done that, we can hit the close button and it'll go and close that out and finish that out and unlock the monitor. Okay, so what we've got to go do now is to go into DisplayCal. So DisplayCal is a free open source, very sophisticated front end for Argyle CMS, which is a highly renowned open source color management system. So to start off, the easiest thing to do is to go through and do the initial setups here. So you can see here we have a video LUT for 3D LUT for Resolve. So we just click that and it'll start loading different profiles. So here's our instrument. So we just click the little button there just to make sure that the instrument's connected all okay. And then one of the really important things here is this area here. So the output levels we can leave it auto. Resolve is actually handling the scaling of the output into our monitor for us, but what we need to look at is our correction profiles as well. So there's various correction profiles. Normally you would select the RG phosphor, but there you can also get available from DisplayCal's website various spectral, so you can type in a 319 and people have uploaded their files for that. So we'll be creating some files with a CR300, but to match the CN7 calibration we must choose the RG phosphor EDR, and the correct one for this to match CN7 is this one. You can hover across it and you'll see the name, and this means that you'll have a matching white balance. So the next tab we want to go to is the calibration tab. Our white point is 3127. Now the calibration is normally a pre-setup within the DisplayCal for an ICC profile, which is what this system is sort of based on. But everything here we just leave as measured. The profiling, we've got an XYZ LUT because we want to create a 3D LUT. That's why it's automatically selected that when we've gone to our resolve here. The test chart here, auto-automized, that's a good selection, and you can go and then choose the patch range that you want. So the more patches you have, the higher the quality of the profile is going to be. So it comes up with 1553 standard, but it's not a bad idea sometimes to do like 17-point profiles. But for this little exercise, we're going to do just a small one of 175. And then we give the profile a name, and we'll call this CG319X. DisplayCal. LUT will be good. Okay. So then with the next page we have our 3D LUT. Now the 3D LUT is not active if it's greyed out. You simply go up to the options here and you click the Enable 3D LUT tab. So you choose your source colour spaces, which is the standard we're trying to calibrate to, if you like, and the BT709. So we're not going to be doing 1886. You can if you like, but we're going to be doing these standard calibration of 2.4. So you can just select 2.2 and then select 2.4. Now in this situation we're going to be choosing relative, so you have two selections, relative and absolute. You choose relative because what it will do is create a 2.4 gamma curve from the measured black point. If you choose 0 of absolute, then it'll basically create a gamma curve from effective 0 nit. which is not what we want unless you have an OLED that can basically measure down to 0. So we want that at relative. We don't want to apply the calibration VCGT, the video card gamma table curves to this. We've already calibrated our monitor using Color Navigator 7, so we don't want to do that. We do want to use some absolute colorimetric with white point scaling, and the LUT size we want to do is a 17 or a 33, so we choose 17. The LUT scaling, we want it to be a full range LUT for the CG279 and the CG319. So once we've done that, we go to Calibrate and Profile, and because we've chosen Resolve, we're using Resolve as a patch generator. So therefore we need to go and set up Resolve to go and talk to DisplayCal. So to do that, we simply select our Resolve. We're in the color page, and we go to the monitor calibration, and we select Portrait Displays CalMan for this. And we type in our 192.168.1.105. Don't hit enter, otherwise it'll reset for you, just press the connect button. And now that's connected, and we're ready to go back into DisplayCal for our... So once we've done that, we'll get this screen up here on your viewing monitor, but it'll output the patches from Resolve. So it shows starting up the instrument. Make sure obviously your probe is flush onto the screen in the center over the patch, and it'll start going through its little setup. You'll see on that screen it'll be going through a little grey setting up the instrument. So what you can do now, you can actually just go and just set a start measurement. This is for actual manual calibration, just to set the RGB levels and the luminance levels, but we're just going to use this as a check to make sure the reads are all okay before we start the actual profile itself. So we're not going to adjust anything here, it's just purely I'd use it as a check. So it'll go through the red, green and blue, then get onto the white, and it'll just measure the luminance of the white for you like that. So that's all working, it's measuring okay. So we hit the stop measure, and then we hit the continue on to profiling, and you'll get this little thing up here. If you want to turn the clicky sound off, you can hit that button there, and this will take a little while. So depending on the size of the patch profile you're doing, the time taken will vary. So it'll end up coming here. You can see this will take a couple of minutes, but it's actually done in 2 parts, so it'll take a little bit more than that. So it'll go through this and then start doing its calculation. So this will take a few minutes, and we'll come back and see how we've gone. So once that's done, it starts to go and do its measurement sums and creating the profile and then the 3D LUT from there. So once we've done that, we then get the dialog to go and save our 3D LUT. It will default to the Blackmagic LUT position for you, which can be quite convenient, but in this case we're not going to be using the LUT within Resolve itself, we're going to be loading it into the monitor. So to do that, we then go and choose a specific place where you might want to put the LUT. And in this case we're going to choose our little file here. So that's now saved the 3D LUT from DisplayCal. So what we need to do now is to go back into Color Navigator 7 and load the 3D LUT using Color Navigator 7. So we start up Color Navigator 7 again, and we get this familiar little dialog box saying OK. So it starts now talking to the monitor, so you've got DisplayCal. So what we need to do is, under this Advanced Functions, the little arrow key, we need to choose the Emulation Log View LUT. So what that does is that will allow us to go and choose our LUT and load that LUT up into the file itself. So now that LUT is loaded within the CG319 or your CG279, and once we've done that, we can now go and verify that LUT. So with the verification, we've got our system setups we've had here. So what we need to do is we need to go and select the simulation profile. So what are we going to compare our calibration to. So there's a whole series of different choices you can make, and we're going to be doing it to the Rec 709 BT, OTUR BT709. We don't need to go and worry about the device link profile, because this is not a profile, this is actually a measuring of the 3D LUT into the monitor itself. And once we do that, we hit the report, and it'll ask us where we would like to put that report, and we choose a file, position, or we can choose here, so we don't get confused, and then it says start the measurement again. And so you can choose the amount of patches you want to go and measure, and to compare how many colours, again making sure that the probe is all good to go. So you can run this periodically if you like, just to check your monitor as well. It's quite useful. Okay, so once we've done that, we then get the profile report come up. So what we want to do here is just tick this use absolute values, because that's against the measurement. And then we can go and have a bit of a look at the results we've got here. So you can see here, we've got actually very, very good results looking at the grayscale measured luminance and the colours that we've chosen. So, and you can go and have a look at the various gamma reports and how the different plots and where things were plotted within the lab. So you can choose an XY value if you like. So here you can choose lab, or you can choose the XYY if that's better for you. So once we see that, we can say yes, we've got a very accurately calibrated monitor that we're extremely happy with. So that's how you calibrate the EIZO CG319X and the CG279X using DisplayCal with the combination of Color Navigator 7. Thank you for watching.